In these examples, we are looking for roots of numbers. Finding a root is the inverse or opposite of raising a number to a power. If we look at example A, we're being asked to find the square root of 25. That means we're looking for the number that when you square it gives you 25. For these, it really helps to know your square numbers. If you do, you'd know that 5 squared is what gives you 25. Taking the root is the inverse. Going back from 25 to 5 is taking the square root of 25. The answer to that then is 5. In example B, we have to find the square root of 36. Again, we're looking for a number that when you square it will give you 36. And if you know your square numbers, you will know that 6 squared equals 36. So the square root of 36 is just 6. In part C, we're looking for the square root of 81. That is a number that when you square it gives you 81. And if you know your square numbers, you'll know that's 9. 9 squared is 81. So the square root of 81 is 9. Here's a quick extra something for those who want to think about it. What is negative 9 squared, by the way? What is negative 9 squared? We're not going to go into this in detail in this lesson, but you will come across it in the algebra videos. In example D, we are now looking for the third root of 8. It's also known as the cube root of 8. That means we're looking for a number where when we raise it to the power of 3, we get an answer of 8. If you don't know your powers of 3, then the way to do these questions is effectively by testing out numbers and seeing if they work. So let's start with something small. Does 1 to the power of 3 equal 8? No, it doesn't. 1 to the power of 3 is 1 times 1 times 1, which is just 1. Let's try the next number, 2. Does 2 to the power of 3 equal 8? Yes, it does. 2 times 2 times 2 is 8. So the cube root of 8 is 2. In example E, we're looking for the cube root of 125. This is easy if you know your cube numbers, but if not, what we're doing is we're looking for a number that when we raise it to a power of 3, it gives us 125. Just to be clear, raising something to the power of 3 is the same as cubing it, which is why doing the inverse is called taking the cube root. If you don't know the answer off the top of your head, testing out numbers is the way to do this. I'm going to list out the cube numbers because they're well worth learning if you don't know them already. So for this one, 5 is the number that we need to cube to get an answer of 125. And that means the cube root of 125 is 5. In example F, we have to find the square root of 7. You will not be expected to find an accurate answer for this without using a calculator, because 7 is not an exact square number. There is no nice whole number that you can square to get an answer of 7. So for something like this, you would need to use your calculator. On your scientific calculator, you should have a button that looks like this. You need to press this button and then the number that you want to find the square root of. So if you were to press the square root button and then 7, you'd get an answer of 2.6457, which I'm going to round to 2.65 to 2 decimal places. Example G is something you might be able to work out without using a calculator if you remember how to multiply decimals. If not, use that square root button on your calculator and enter 0.36 after it, press equals, and you'll get the answer of 0.6. To check if this makes sense, remember what this means. If the square root of 0.36 is 0.6, That means that 0.6 squared should equal 0.36. Let's just check that out. 0.6 squared means 0.6 times 0.6. And if you remember how to multiply decimals, you'll remember that that is going to give us 0.36. So we know that this is correct. Moving on to example H, we've now got to find the cube root of 1.331. So we're looking for a number that when we cube it, it gives us 1.331. This is not something you'd be expected to do in your head. If you use a calculator, you would need to use the cube root function. Now, on most calculators, you would need to press shift or second function and then your square root button. This should show the cube root symbol on your calculator display. It's very similar to the square root symbol, but it's got a little 3 at the beginning. You then type in 1.331 and hit equals, and you should get an answer of 1.1. Let's just check that. Is 1.1 to the power of 3 equal to 1.331? You can pop that into your calculator and you will see that it is. So we know that 1.1 is correct. In this example, we're looking for the fourth root of 81. That means we're looking for a number that when we raise it to the power of 4, we get an answer of 81. This is easy if you know your powers of 4, but if not, you can make a list. So 3 is the number we're looking for here. This happened to be one that had a nice whole number answer. For the remaining examples, you would be allowed a calculator. You wouldn't be expected to work these out in your head. Notice that in all of these cases now, we're not looking for a square root or a cube root. We're looking for higher roots, a fourth root, a fifth root, and a sixth root, respectively. You don't have separate buttons for these on your calculator, so you have to use a specific function. You should see somewhere on your calculator a function that looks like this. On most scientific calculators, this is not on its own button, but it's a second function to another button. That means you'd have to press shift or second function on something else to get to this. Most commonly, it's on the x to the power button, so you'd either have to press shift or second function and the x to the power button to access this function here, which lets you calculate higher roots than the square root or the cube root. To work out the fourth root of 130, you would have to access this function and then make sure you put a 4 in that bit there and 130 in that box there. Then you hit equals and you should get an answer that begins 3.3766 and so on. I'm going to round that to 2 decimal places to 3.38. We're going to use the same function on the calculator again. So we access this and then we need to fill in the number 5 because we want the fifth root, and then the number 61 under the root sign. And this should give you an answer that rounds to 2.28 to 2 decimal places. Finally, let's get a little bit more practice. Do the last example. We're going to use the same function again. This time we want the sixth root of 9,032. If you put those numbers into the correct place, you're going to get 4.56 to 2 decimal places. Now that you've seen the video, you should be comfortable doing 2 things. 1, you should be comfortable finding any root of any number using a calculator. And 2, when you've got exact square numbers or some small exact cube numbers, you should be able to find the square root or cube root of those without needing a calculator.